Preparation of RRBJ, SSCJ and other exams like DMRCJ and State Engineering J exams require in-depth knowledge of the subjects. Gradeup, India's largest exam preparation platform, brings to you a dedicated YouTube channel for RRBJ and SSCJ aspirants. Subscribe to Gradeup RRBJ and SSCJ exam channel today and stay updated for the exam.
Hey you guys over there, I hope you all are doing well, and today I'll be teaching minimization in theory of computations. Guys, sorry for being a bit delay as we are settling the things over here. So the topic of today's lecture will be minimization of DFA, and this is the brief about me. I have 4 years of teaching experience in GATE. I did masters from NIT Bhopal. I'm the senior faculty in CS department over here. I qualified this exam for 4 times and I have expertise in TOC, algorithm and DBMS. And this session is on again theory of computations. So how are you all guys? I hope you are doing well. And okay, Dark Knight Jello, how are you? Seema, hello. Good evening Shiva, how are you? I hope you all are doing good. Satyam, good evening. Chetan, good evening. Pratibha, very good evening. How are you? Guys, what I want from you is just spread this video as much as possible so that the aspirants like you will get maximum benefit of sessions like this. Sheetal, good evening. Uma, good evening. Okay. So let's start this topic with that is minimization of DFA. Now, what do you understand by first minimization of a DFA? Now, DFA minimization is nothing but minimizing the number of states of an DFA. Yes, Sachin, good evening. How are you? Dark Knight, Ram Sa. Okay. So minimization means we are minimizing the number of states inside a DFA. Now see over here, let's assume a simple DFA which contains some state. So I am drawing one DFA. Let's say it has a state Q0 and that state is again a final state. And it has 2 different transitions for A as well as for B. While reading A at Q0, let's say it approaches to Q1 named state, and at Q0 while reading B it reaches to Q2 named state, and at both these states we have some transitions like AB. So can anybody tell me what is the language accepted by this automata? What is the language accepted by this automata? It has 3 different states. Q0, Q1 and Q2. At Q0, after reading A, we are approaching to Q1. At Q0, after reading B, we are approaching to Q2. So what should be the language accepted by this automata? Can any one of you answer it? Guys, empty string. Somebody wants to say that it will accept epsilon. Epsilon means without reading anything, we are at the final state. So as you see that it's just accepting epsilon, and there are so many other states with this automata. We can do what? We can club non-essential states together. To minimize such kind of automatas. For example, see, I'm drawing it again, and now I'm drawing something like this. We have final state at Q0, and from here we have a transition for A and B, and after reading this, we are approaching to a state named as Q1, where we are again having a transition of self loop of A and B. See, this automata and the automata in the previous page is same. This automata is accepting epsilon, and if you look at over here, then this automata is again accepting epsilon only. This automata is accepting epsilon only. Although this automata has only two states. On the other hand, the previous automata is having how many states? This was having 3 states. So there might be a possibility that if you draw an automata with some number of states, then that automata can be minimized. That automata can be minimized like this example only. Let's assume one more example. If you have an automata, see, let's say something like this. At Q0 you have a final state. At Q0 you have a final state, and after reading what? A comma B, you're staying at Q0 only. And you have another automata named as, you have another state named as Q1, and here you have another self loop of A and B. So in this case, can we minimize it? Can we minimize that automata? What should be the possibility, or what should be the minimum number of states in this scenario? Can anybody tell that what should be the minimum number of states in this scenario? Yes, guys, I am waiting. What should be the minimum number of states in this scenario? Abhijit says 1. Chetan says 1. Dark Knight says 1. Remove Q1. Okay, remove Q1. He says remove Q1. Single state, Sachin Parmar. No, it's already minimum. One state. No, it's very difficult. It's not difficult, it's very easy, Shivam. Okay, here, whenever you do something like this, then you can't minimize that automata more. Means you should have a final state as well as a non-final state in your minimum automata. You should have a final state as well as a non-final state. We can't minimize it. I'll tell you why. We'll try to solve many problems. And yes, that is an unreachable state, but this is again the minimum automata. In this case, we'll have only 2 states. We have only 2 states in the minimum automata. Although this state is not reachable by Q0, but still we have 2 states. For example, if at all it is asked in your exam something like this. Let's say your DFA has around 50 states. And out of those 50 states, let's say 30 states are final. And if at all your DFA has 20 more, means out of 50, 30 is consumed as final state and remaining will be 20 non-final states. Then in the best possible case, if we minimize this automata, we'll get 1 as final state and we'll get 1 as non-final state. So after combining this, in the best case, this automata will have 2 states. Yes, Q1 is the dead state, but we'll not remove it from the automata. Q1 is the dead state, but we'll not remove it from the automata. See, I'll try to explain it more. by the help of some examples. So you will definitely get the concept. See, first of all, just try this question. The things which I've already told you, are you able to solve this question or not? See, the question is minimal finite automata for the given FA contains always, it's saying always less number of state. Is it possible that it will always contain less number of state, or it may contain less number of state, or it can contain more number of states, or none of the above? What should be the answer? Guys, out of A, B, C, D, what should be the answer? Okay, somebody is saying B. Chetan is saying B is the answer. Gyan is again saying yes, Gyan B. Satyam B. Vishnu B. Yes, everybody is getting. Uday is saying A. See, what does this means? First of all, let's say your DFA is having, let's say your DFA is having 10 states, and we are applying some minimization over it, When we are applying some minimization over it, then this doesn't guarantee that it will always contain less number of states. Are you getting my point? There might be a possibility that it can have same number of states, means it can have 10 number of states in the DFA, or it can have less than 10 number of states, So this is the situation. If your DFA is having 10 in all 10 states, then after minimizing it, it's not guaranteed that it's always having the less number of states. This is not guaranteed. It can have less number of states. Or something like this. It can have equal number of states. So we can say it may. We can't say that it will always. Will be wrong answer. We can say it may. So that's why B is the correct answer. Now let's try one question that is based on minimization, and in this there are 7 states. A transition table is given of 7 states starting from Q0 to Q7, and we need to figure out that what is the minimum state automata for this. Guys, can you try it? Just try to solve it. I'll tell you the trick how you can do this. Final state is Q2. The star is smaller, so I guess you are not able to see it. Karan Patel, final state is Q2. Yes, guys, try. If you'll try it here, then you will be able to crack that question in exam. Q7 remove. Sachin Parmar, I'm not getting. What do you want to say? Q7 remove. Okay, Jyoti has got the answer. 4 number of states will be there in the minimum automata. So let me try. See, what you need to do if questions like this comes in your paper. And this is a very trending topic. And many times, many questions have asked in many different exams like NIT as well as in GATE over minimization of automata. Guys, look over here how you can approach this question. See, first of all, I'm writing pi. Pi means all combination of states. Pi means what? Pi is nothing but all combination of states, that is starting from Q0, Q1, Q2, then Q3, Q4, Q5, Q6 and Q7. So this is nothing but all the states which are given in the automata or which are given in the question. Next, you need to calculate pi 0 for it. You need to calculate what? You need to calculate pi 0 for it. Now pi 0 is what? Pi 0 is nothing but the separation of states where we separate two different sets for final as well as non-final states. Are you getting my point? Pi 0 is what? Pi 0 is the condition when we split our automata into two different states. We have only one final state. So at that time when you write pi 0, you need to write something like this. There will be two different states or sets one is containing Q2 and another set will contain all the remaining states. That is nothing but starting from Q0, next will be Q1, the next will be, as Q2 is already occupied in another state set, so we'll not take it, we'll take Q3, then Q4 followed by Q5, Q6 and Q7 and Q7. Okay, are you with me? What I did is I separated final state from non-final states. At pi equal to 0, at pi is equal to 0, I separated final states with non-final state. Now next is we need to analyze this table. We need to do what? We need to analyze this table. Yes, that is also called as zero equivalent. Karan, you are correct. Pi 0 is nothing but zero equivalent. Yes. Now what I am saying is we need to analyze this table, and after analyzing, okay Gyan, your answer is correct. There will be around 5 states, I guess. Okay. Now we need to analyze this states. Let me solve this for you. Next, you need to calculate 1 equivalent or pi 1 or pi 1. How you can calculate pi 1? Already Q2 is in another set, so we'll keep it as it is. We'll identify or check for Q0 and Q1 that they'll remain in this non-final set or not. Then how you can do that? How you can do that? To do that, you'll see on Q0, after giving 0, we are moving to Q1 named state. We are moving to Q1 named state. On Q0, after giving 0th symbol, we are moving to Q1 state. I'm talking about these two. I'm talking about what? I'm talking about these two. First is this, second one is that. So I'm talking about these two states. On Q0, after reading 0, we are moving to Q1, and on Q1, after reading 0, we are moving to Q6. We are moving to Q6. Now just check that Q1 and Q6 are belonging to same set or not. So in the previous sets, we need to check that. We need to check what? We need to check that Q1 and Q6 is in the same set or not. So see, Q1 is here and Q6 is also available here. It means we can keep Q1 with Q0. This means we can keep Q1 state with what? Q0 state. Fine. I hope you are understanding. I hope you are understanding this stuff, and I'm explaining it in a very easier way. Next is we need to check it for Q3. Next is what? Next is Q3 state. Now check for Q3 with Q0. Is it possible to keep Q3 with Q0? Q3 and Q0. At Q0, after giving 0, we are going to Q1 state, and here we are going to Q2 state. Now check that Q1 and Q2 are in same set? No, they are in different sets. Q1 is in other set and Q2 is in another set. So we cannot keep Q3 with the Q0. So for that, for Q3, we need to create a new set. So I am creating a new set over here. Okay, so this will be Q3. So this will be what? This will be Q3, guys. I am creating a newer set for Q3 because we can't keep it Q0 with Q3. Are you getting, guys? Or is there any doubt? Are you getting the concept that we can keep Q3 in different set? We should keep Q3 in different set or not? Yes, guys. Yeah, it's clear. Vishnu is saying it's clear. Okay. Let me continue. I'll do it fast now. As concept is clear to all, I'll do it fast. Okay. So see, now with Q0, we need to check what? We need to check the next state, that is Q4. So with Q0 on Q4, we are observing that it is going to Q1 state and that is going to Q7 state. So Q1 and 7 are in the same state. So we can't take decision right now. Next, check for Q0 on 1. It is going to Q5th state. The Q4 is going to Q5th state. Yes, the Q5 will always be in the same state. Okay, Q5 will always be in the same state. So what we can do, we can keep Q4 over here. We can keep Q4 over here. Okay, so we'll not close that set because there might be a possibility that more states can come inside this set. Fine, guys. Now let's try for Q5 state. Let's try for what? Let's try and approach for Q5 state. Now let's check that Q0 and Q5, what is the answer? Let's check that for Q0 and Q5, what is the answer? Can we keep it in the same state or we need to separate them out? See, for Q0 and Q5, I'm again circling the states Q0, Q5. On Q0, after observing 0, we are moving to Q1 state. On Q5, after observing 0, we are moving to Q2 state. Check Q1 and Q2 are in same set or not? No, Q1 is in this set and Q2 is in another set. So we cannot keep Q5 with Q0. We cannot keep Q5 with Q0. So can we keep it with Q3? Can we keep it with Q3? So in order to check it with Q3, I'm circling Q3 state. Now the transition will become Q2, Q2, which is in the same set, and Q6, Q6, which is again in the same set. So you can do what? You can keep Q5 over here. You can keep Q5 over here. Then last two states are left now. Only last two states are left now. See. Now again check for Q0 with the Q6. As we have completed for till Q5, next turn will be of Q6 state. So Q0 will reduce to Q1 and Q6 will reduce to Q6 only. So check Q1 and Q6 are in same state. Yes, they are in the same set. Now check Q0 for Q1. It will give Q5. Q6 for Q1 will give Q4. Now check that Q5 and Q4 is in the same set. Q5 and Q4, yes, it's clearly visible. It's in the same set. So guys, what we can do, can we keep Q6 with Q0? Q1 and Q6 is in the same set. Yes, it's true. And Q5 and Q4 is in the same set. So it's again true. So we can keep Q6 over here. Okay. So we can keep Q6 over here. Next is what? Next state is at Q0 after with Q7, what will be the thing? At Q0 state, on reading 0th symbol, we'll approaching to Q1 state and Q6 state. Just check that Q1 and Q6, is it in the same set? Yes, it is in the same set. Then next on Q0, after reading 1, it will be going to Q5th state and Q2nd state. But Q2 and Q5 are in different sets. In pi naught, these two are in different sets. So we can't keep it together. So this should be the answer. This should be the answer for pi 0. For pi 1, Q0, Q1, Q4, Q0, Q1, Q4, and this should comes where? Okay, I guess there is something which is wrong in this question. Okay, let me check once. Q0, Q4, Q6. Okay, I did something wrong over here. Let's just check again for Q0 and Q1. Let's check again for Q0 and Q1. Q1 will go to this state and Q2 is a final state. Q2 is the final state. So we can't keep it over here. Are you getting me? I did something wrong. What I did is I kept Q1 here. Fine. I kept Q1 here and that is wrong because Q5 and Q2 are in different sets. So we can't keep Q1 here. So we have to remove this from here. And the set will become what? This set will become Q0, Q4, Q6, and Q1 will be, let's check can it be occupied over here or not? Can it be occupied over here or not? Yes, Q1 will be Q3. Yes, I'm also feeling that it should be with Q3. So let's see that Q1 and Q3. After analyzing Q1 with Q3, okay. Q1 with Q3, Q6 and Q2 should be the output. So 6 and 2, no, they are in different sets. So we should do what? We should keep it in other place. We should keep it in another place, like, okay. Let me solve it again for you, as things are becoming wrong. So from here, let me retrace the things. See, at Q naught state, we are checking Q1. At Q naught state, we are checking what? Q1. So at Q naught state, after checking Q1, what will happen? At Q naught, can we keep Q1 with it? So Q naught on 0 symbol, we are going to Q1 and Q6. So Q1 and Q6 are in the same set. On 1, it's in Q5 and Q2 state. And both are the different sets. So we can't keep Q1 with Q0. We have to create a new set. Fine. Now, I think now everything will be correct. Okay. Now let's see. Okay, guys. Now, as we have checked for Q1, next is the turn of Q3, and we have already calculated that Q3 and Q4 should be in the same set. We have already checked that Q3 and Q4 should be in the same set, but for safer side, I'll do what? I'll check again. For Q0, Q3, just for Q0, Q3, it's going to Q1 and Q2. So Q1 and Q2 are in different sets, so we can't keep it because we did this one step wrong. That's why the entire question was going wrong. So we can't keep it with Q0. Previously I kept it. So where should be Q3? Can it be with Q1? What do you say, guys? Q1 will be with Q3 set. Someone says that Q1 will be with Q3 set. How you can say Q6 and Q2? See, Q6 and Q2 are in different sets. So we can't keep it like this because Q6 is a non-final state and Q2 is a final state. So we can't keep it like that. We need to create a newer set. Newer set for what? For Q3. Now, as we have created another set for Q3, let's check for Q4. Okay, this is Q4 and that is Q0. Now, Q0 and Q4, let's trace it. Q0 and Q4, guys. So Q1 and Q2, final and non-final. Q1 is non-final and Q2 is final. So we can't keep it together. We can't keep Q0 with Q4. Next is the turn for Q1 set. Let's see. In Q1 set, can we keep Q4? Okay, I guess I was looking like this. So this is the problem. Okay, I'll mark arrows. The problem is I'm looking down, so the next state output is appearing to me. So at Q0, see guys, at Q0, after reading 0, we are going to Q1 state. At Q0, after reading 0, we are going to Q1 state, and I need to keep Q4 somewhere. So at Q4 state, after reading 0, I'm going to Q7 state. So see, Q1 and 7 are in same set. So if at all they are in same set, we need to check for 1. So we need to check for 1. Yes, it's Q5. So we can keep what? We can keep Q4 over here. Next, let me check for the next states. That is nothing but Q5. And with Q0, I want to check for Q5. can we keep Q5 with Q0? Can we keep Q5 with Q0? So let me draw the arrows so that the probability of errors will be reduced. So that the probability of errors will be reduced. As usually question will have lines over here and it's not having lines. So that's why the problem is occurring. Fine. So let's see Q5 with Q2. Q5 is with Q2 and at Q0 we are getting Q1. At Q0 we are getting Q1. So Q1 and Q2, these are in different sets. So we can't keep Q5 with Q0. We cannot keep Q5 with Q0. Okay. Let's check with Q1. Let's check with Q1, guys. Okay. Now for Q1, we are getting Q1, Q6 and again Q2. Q6 is a non-final state and Q2 is a final state. So we can't keep it over here too. We can't keep it over here. Okay. Now next do what? Next check it for Q3. That is this state. So you can see that Q3 is giving Q2 on 0 and Q5 is given Q2 on 0 and that state is nothing but a final state. And it's the same state too. So we can keep it with here. We can keep it here, but we need to check for once again. So it is giving Q6, Q6, and by this we can say that we can keep Q5 with Q3. We can keep Q5 with Q3. Okay. So till Q5 is over. Till this Q5 is over. Next check that Q6. What we are doing? Q6. Okay, with Q0 or not. Okay, on Q6, can we keep it with Q0? On Q6, after reading 0, we are getting Q1 and Q6. So Q1 and Q6 are in same set. Now next check for the next state for next transition, that is 1. So we are getting Q5 and Q4. We are getting Q5 and Q4. Q5 is here and Q4 is here. So everything is in the same state. So we can keep Q0 with Q6 over here. We can keep Q0 with Q6 over here. Let's not just close this state because there might be a possibility that Q7 can come. There might be a possibility that Q7 can also join this state. Fine. So now let's try for Q7 set. Okay, it's a very lengthy question, guys. See, at Q0, after observing 0, we are going to Q1 state. Okay, this is the thing, and here we are getting Q6. So 1 and 6 are in the same set. 1 and 6 are in the same set, and 5 and 2 are in the different set. 5 and 2 are in the different set. So we can't keep it over here. We can't keep 7 over here. Then can we check it for Q1? Yes, we can check. Q6, Q6, same set. Q2, Q2, same set. So we can do what? We can keep Q7 over here. So this will be the one equivalent of that automata. Fine. So we need to calculate more till we get the same equivalent states. Till we get the same equivalent states or same pi value Let's try to solve this question. Okay, so pi 0, pi 1 is here. I'll try to write at the bottom now. Pi 2. For pi 2, what is happening? We have Q2 in a separate set. Okay. Then we have Q0 with Q4. Let's check Q0 with Q4 will remain as it is or it will be changed. So Q0 and Q4 after observing 0 will move to Q1 7 and 1 7 are in same set. Q0 and Q4, yes, Q4 is something like this. Q0 is that one. So after observing 0 we are going to 1 and 7 and on the other hand we are going to 5 and 5. So this is nothing but same thing. On Q0 we can keep Q4. With Q0 we can keep Q4. Fine. Now let's check for Q6. Can we keep Q6 with Q0? Can we keep Q6 with Q0? On Q6, after observing 0, we will moving to Q6 state, and here we are moving to Q1 state. So Q1, see, Q1 is here and Q6 in the other state. So both are the different sets. Both are the different sets. So we can't keep Q6 with this set. This will become a newer set named as Q6. This will become a newer set named as what? Q6. Now let's check for Q1 and 7. Can they come together? Can Q1 and Q7 come together, guys? Let me try. Can Q1 and what we are going to check, Q7, can both of them come together? Now after giving 0 as input, it is going to Q6 state, and that is also going to Q6 state. So both the states are equal, then they will be in the same set. It is going to Q2, then that will be again the same set. That will again be the same set. So Q1 and 7 will be together. So Q1 and Q7 will be together. Next, last is what? Q3 and Q5. For Q3 we need to check, can we keep 3 with 5? Can we keep 3 with 5 or not? Okay. So let me check for 3 and 5. This is 3, that is 5. Now at Q3, after analyzing 0, it is moving to Q2 state. At 5, this is moving to Q2 state. Both the states are same. And here we are moving to 6th state and 6th state. So again, both the states are same. So we can easily keep Q3 with Q5. Now just check that Q1 equivalent, 1 equivalent and 2 equivalent. Yeah, pi 1 and pi 2, both the values are same or not. So we have Q2, we have Q0, Q4, Q6, but here we have Q0, Q4. So both are not same. We need to calculate more. We need to calculate this question for more number of iterations. Let me try the next iteration for you. Okay. So I am writing the next equivalent state, that is nothing but pi 3. That is nothing but pi 3. So here we can keep Q2 separately. Yes, we can keep, as it's the single state only. And we can keep Q6 separately. We can also keep Q6 separately. So both these states are separate, guys. Both these states are what? Separate. We need is to check for Q0, Q4, Q1, Q7 and Q3, Q5. So let's do it. Can we keep Q0 with Q4, guys? Can we keep Q0 with Q4? How many of you can say, can we keep Q0 with Q4? Okay, Karan has already given the answer. Q0, Q4, 6, 1, 7, 2, 3, 5. Okay, Shahid has said Q0, Q4. Somebody is saying Q5 will be with Q3. Yes, it's with Q3. Vishnu is saying Q5 is with Q3. Yes, it is with Q3. Can we keep, guys? Can we keep Q0 with Q4? Okay, see, I'll try. 5 states. Okay, somebody has already solved. Yes, somebody is saying yes. Okay, fine. Let me solve. Q0 for Q4. Q0 for Q4. See, Q0 for Q4 will be this. Q1 and Q7. Q1 and Q7. Now, what will happen? See, 1 and 7 is where? 1 is here and 7 is in the next state. So, we can keep it. No, we need to check further. We need to check further for the one transition, and here one transition is giving Q5 and Q5. So, we can keep Q0 and Q4 together. So, first thing is we can keep Q0 and Q4 together. Next is we have already written Q6 separately. We need to check for Q1 and Q7. Can we keep Q1 and Q7 together now? Okay. Q1 and 7. So let me circle it out so that it can be visible properly. Okay, Q1 and Q7. At Q1, after analyzing 0, we are going to Q6 state. Here we are going to Q6 state. So both these states are same, so we can keep till now. Next is after analyzing 1, we are going to Q2 state and Q2 state. So both these states are again same, so we can also keep this Q1 and Q7 together. We can keep Q1 with the Q7 as both these states are yielding to same states. Here it is going to Q6, this one is going to Q6, that one is going for Q2, and it is also going to Q2. Next, let me check for the last set of this question, that is Q3 and Q5. For Q3 and Q5. Okay guys, for this can Q3 can come with Q5 or not? So here let me circle it out, Q3 and Q5. After analyzing, we are going to Q2. Both are the same states. On the other hand, we are going to Q6 and Q6, and both are Q6 will always be in the same set. So by this we can say that Q3 can come up with Q5. So let's check that is the pi equivalent 3 is equal to 2 or not. So here we have what? Here we have Q2 and Q2. We have Q6, Q0 is with Q4, and Q1 is with Q7, and Q3 is with Q5. So now we have done it correctly. The problem with me was I was looking down, so at that time I thought that Q5 is with Q6 with the lower level state. So that was the problem. The question was something like this. Okay guys, so till now what we have figured out is we have figured out the pi value. Pi value is what? Pi value is 3, and these are the states Q2, Q6. See, Q2, Q6, then Q0, Q4, then Q1, Q7, 1 is with 7, then 3 is with 5. So now what we can do from here now? We can minimize this automata, guys. We can minimize this automata like this. See, we can replace 4 with zeros. We can replace the state 7 with Q1 state, and we can replace 5 with third state. So I'm doing it now. I'm replacing 4 with 0. So Q0 will be replaced by Q4. Okay, that's okay. Q0 will be replaced by what? It will be replaced by 4. Fine. Q0 will be replaced by 4 at every place. Wherever you see Q0, you can replace it by Q4. See, is there any other Q0? No. Only one place Q0. Okay, that's it. Next, we need to check for Q1 and Q7. Is there any short method for minimization? No, guys. We don't have any short method for minimization. The next method will be table filling. So I'm going to check for Q1 and Q7. See, sorry, I'll be replacing Q7 with Q1. So you can do what? You can replace Q7 with Q1, or you can replace this. Anything can happen. If you want to replace this Q1 with 7, then this will become Q7. That will become again Q7. And any other place where we can find Q1? No. We are not able to find Q1 anywhere else. Next is Q3 with Q5. So in place of 3, I'm writing 5. So where is 3? 3. Here is 3. I'm writing 5 over here. Then can you see any other 3? No, only one. So just look what is the thing which we got now. See, we have got a state named as Q4. This is nothing but same as this state, Q4, Q7, Q0, or you can say that it can be treated as Q0. It can be any. So there is no need of writing this 2 times, Q4, Q7 and Q5. See here again Q4, Q7 and Q5, and here again you can see clearly Q4 is coming with Q7 with Q5. On analyzing the same strings, we are going to same state. Fine. Next is what? Q7 is coming with 6 and 2. See, Q7 is coming with 6 and 2. So it's again a repeated state. So we can remove it from here. Q7 is coming with 6 and 2. So that can be removed. And the next is Q5 is coming with 2 and 6. So Q5 is coming with 2 and 6. So that can also be removed from here. Then the minimum automata will have how many states? First state, second state, third one is this, fourth one is this, fifth one is this, and sixth one is this. Is it right? We have 1, 2, 3, 4, 5. Okay. Again, I have missed something here. What is missed? See, we have replaced what? We have replaced 2, 6. We have replaced 6 for 4, Q0 for 4, Q0. Okay, Q5 is coming 2 times. See, Q5, Q2, Q6, Q5, Q2, Q6. So this is also be eliminated. So we'll get first state as this, second state as this, third one is this one, then fourth one is this, fifth one is that. So this is the exact answer for this question. I hope everybody has got the same answer. Okay, Q0, Q4, 6, 1, 7, 2 and 3, 5. Yes. Okay guys, so as we don't have much time, so today I'll be giving you one question. Try this by yourself, and whenever we meet again, we'll try to solve this question. So what you can do, just note it down, and whenever we meet again, we'll try to solve another minimization question, and in that I'll be teaching that question to you. As time is not permitting me now, and we have to leave it over here. So guys, take this question and do it. So I hope you might have understand a bit about minimization. The question is bit lengthy, but it is doable. Once you know the trick, then you can solve that question too. Hello guys, have you noted down? Have you noted that question? So whenever we meet next time, I'll make sure that we'll try to solve this. Sir, replacement कैसे की है states की? Okay. What I did is I replaced 4 by 0. I replaced 7 by 1, or I can say that I replaced 0 by 4. I replaced 0 by 4. I did this. I replaced 0 by 4. Then 0 is replaced by 4. Then I replaced 1 by 7. Replaced 1 by 7. And at last I replaced 3 by 5. So no matter what you do, you'll get the answer. Because we need to calculate the minimum number of states. The name of state is not important, because you can even name it as A, B, C, as it is Q4. You can name it as X or Y2. So it can be anything. Name can be anything. I replaced it like this: Q0 with Q4, Q1 with Q7, and Q3 with Q5. So here, when I replaced Q0 with Q4, I figured out that Q0 is having same values. Q4 is having same values over here and there. In the same way, I figured out that Q7 is having same transitions. Q7 is also having same transitions over here and there. And again, at last, I figured out what? That Q3 state is having same transition as of this state. So that's why I deleted Q4, Q5, Q7. I deleted what? I deleted Q4, Q5 and Q7, and I replaced their name by these three states, When I did that, then the minimum automata comes into picture. Okay, I hope I solved your doubt. Okay, is there any other question, guys? Okay. So as the next session is going to be live now, so I need to take a permission from you, and we'll be meeting in the next few days or in the next class. By the time, I would like to tell you that you can get the green card of Gradeup for a yearly at 499 rupees and the monthly card at 299 rupees. And at last guys, prep smart, score better, go Gradeup, guys. Now if you have any doubt, you can ask. Okay, in last column, in question, last column. Okay, I'm going back. Sundar is asking in last column. Yes, man, yes. What is there in the last column? Yes, Chetan, thank you for joining us. What happened, Sundar, in the last column? I can't read your comment completely. Sundar, okay guys, okay, fine. Sir, please provide questions. Okay, I already provided one. You can try this, Abhijit. I already provided one question. Q7, okay, Q7 is not visible. Okay, Pratibha said that last column is not visible. Even when I'm looking like this, so I feel that the next state is this for this. So it's quite difficult to look over from the top. So if the question will be in front of me, then that will be very easier to solve. Yes, Q7 it's not visible. Okay, I got it. The last question, last column is not visible. So we'll try to modify that in the next PPT. Okay guys. So with this, I would like to thank you all for joining us. And with this, I would like to end this session over here. Thank you. We'll meet again soon.